Okay, hi everyone, welcome back to this video series on Comptia Security Plus XSS and XSRF. Two web application vulnerabilities to watch out for include cross-site scripting XSS and cross-site request forgery XSRF. XSS holds are vulnerabilities that can be exploited with a type of code injection. Code injection is the exploitation of a computer program bug or flaw by inserting and processing invalid information. It is used to change how the program executes data. In the case of an XSS attack, an attacker inserts malicious scripts into a web page in the hopes of gaining elevated privileges and access to session cookies and other information stored by a user's web browser. This code, often JavaScript, is usually injected from a separate attack site. It can also manifest itself as an embedded JavaScript image tag, header manipulation, as in manipulated HTTP response headers or other HTML embedded image object within emails that are web-based. The XSS attack can be defeated by programmers through the use of output encoding, JavaScript escaping, CSS escaping, and URL encoding. By preventing the use of HTML tags and by input validation, for example, checking forms and confirming that input from users does not contain hypertext. On the other user side, the possibility of this attack's success can be reduced by increasing cookie security and by disabling scripts in the ways mentioned in the first section of this chapter. Securing the browser. If XSS attacks by email are a concern, the user could opt to set his email client to text only. The XSS attack exploits the trust a user's browser has in a website. The converse of this, the XSRF attack, exploits the trust that a website has in a user's browser. In this attack, also known as a one-click attack, the user's browser is compromised and transmits unauthorized commands to the website. The chances of this attack can be reduced by requiring tokens on web pages that contain forms, special authentication techniques, possibly encrypted scanning .xml files which could contain the code required for unauthorized access, and submitting cookies twice instead of once while verifying that both cookie submissions match. More code injection examples. Other examples of code injection include SQL injection, XML injection, and LDAP injection. Let's discuss these briefly now. Databases are just as vulnerable as web servers. The most common kind of database is the relational database, which is administered by a relational database management system, or DBMS. These systems are usually written in the structured query language SQL. An example of an SQL database is Microsoft's SQL Server, pronounced SQL. It can act as the back end for a program written in Visual Basic or Visual C++. Another example is MySQL, a free open source relationship database often used in conjunction with websites that employ PHP pages. One concern with SQL is the SQL injection attack, which occurs in databases, ASP.NET applications, and blogging software such as WordPress that use MySQL as a back end. In these attacks, user input in web forms is not filtered correctly and is executed improperly, with the end result of gaining access to resources or changing data. For example, the login form from a web page that uses an SQL backend, such as a WordPress login page, can be insecure, especially if the front-end application is not updated. An attacker will attempt to access the database from a form in a variety of other ways. Query the database, find out a user, and then inject code to the password portion of the SQL code, perhaps something as simple as x equals x. This will allow any password for the user account to be used. If the login script was written properly and validated properly, it should deflect this injected code, but if not, or if the application being used is not updated, it could be susceptible. It can be defended against by constraining user input, filtering user input, and using stored procedures such as input validation forms used to save memory. A stored procedure is a subroutine in an RDBMS that is typically implemented as a data validation or access control mechanism, which includes several SQL statements in one procedure that can be accessed by multiple applications. When using relationship database such as SQL, MySQL, a programmer works with the concept of normalization, which is the ability to avoid or reduce data redundancies and anomalies, a core concept within relational DBs. There are, however, other databases that work within the principle of denormalization and don't use SQL or use code in addition to SQL, known as NoSQL database. They offer a different mechanism for retrieving data than their relational database counterparts. These are commonly found in data warehouses and virtual systems provided by cloud-based services. While they are usually resistant to SQL injection, there are no SQL injection attacks as well. Because of the type of programming used in NoSQL, the potential impact of a NoSQL injection attack can be greater than that of an SQL injection attack. An example of a NoSQL injection attack is a JavaScript object notation JSON injection attack, but NoSQL databases are also vulnerable to brute force attacks, cracking of passwords, and connection pollution, a combination of XSS and code injection techniques. Methods to protect against NoSQL injection are similar to the methods mentioned for SQL injection. However, because NoSQL databases are often used within cloud services, a security administrator for a company might not have full control over the level of security that is implemented. In these cases, careful scrutiny of the service level agreement SLA between the company and the cloud provider is imperative. LDAP injection is similar to SQL injection. So I'm after losing where I am now. Okay, just give me a minute now. NoSQL databases are vulnerable to brute force attacks, cracking of passwords, and collection pollution, a combination of XSS and code injection techniques. Methods to protect against NoSQL injection are similar to the methods mentioned for SQL injection. However, because NoSQL databases are often used within cloud providers, a security administrator for a company might not have much control over the level that is implemented. In these cases, careful scrutiny of the service level agreement SLA between the company and the cloud provider is imperative. LDAP injection is similar to SQL injection, again using a web form input box to gain access or by exploiting weak LDAP lookup configurations. The lightweight directory access protocol is a protocol used to maintain a directory of information such as user accounts or other types of objects. The best way to protect against this, and all code injection techniques for that matter, is to incorporate strong input validation. XML injection attacks can compromise the logic of XML, extensible markup language applications, for example, XML structures that contain the code for users. It can be used to create new users and possibly obtain administrative access. This can be tested for by attempting to insert XML meta characters such as single and double quotes. It can be prevented by filtering in allowed characters, for example, AZ only. This is an example of default deny, where only what you explicitly filter in is permitted, everything else is forbidden. One thing to remember is that when attackers utilize code injection techniques, they are adding their own code to existing code, or are inserting their own code into form. A variant of this is command injection, which doesn't utilize new code. Instead, an attacker executes system level commands on a vulnerable application or OS. The attacker might enter the command and other syntax into an HTML form field or other web-based form to gain access to a web server's password files. Once again, the best way to defend against code injection, command injection techniques in general, is by implementing input validation during the development, testing and maintenance phases of the SDLC. Directory traversal. Directory traversal, or the // attack, is a method of accessing unauthorized parent or whose root directories is often used on web servers that have PHP files and are Linux or Unix based, but it can also be perpetrated on Microsoft operating systems, in which case it would be, or the // attack. It is designed to get access to files such as ones that contain passwords. This can be prevented by updating the OS or by checking the code of files for vulnerabilities, otherwise known as fuzzing. For example, a PHP file on a Linux-based web server might have a vulnerable if or include statement which, when attacked properly, could give the attacker access to higher directories and the password file. Zero-day attack. A zero-day attack is an attack executed on a vulnerability in software before that vulnerability is known to the creator of the software and before the developer can create a patch to fix the vulnerability. It's not a specific attack, but rather a group of attacks including viruses, trojans, buffer overflow attacks, and so on. These attacks can cause damage even after the creator knows of the vulnerability, because it may take time to release a patch to prevent the attacks and fix damage caused by them. It can be discovered by throughput analysis and fuzz testing. Zero-day attacks can be prevented by using newer operating systems that have protection mechanisms and by updating these operating systems. They can also be prevented by using multiple layers of firewalls and by using whitelisting, which only allows known good applications to run collectively. These preventative methods are referred to as zero-day protection. Chapter summary. Without applications, a computer doesn't do much for the user. Unfortunately, applications are often the most vulnerable part of a system. The fact that there are so many of them that they come to form so many resources can make it difficult to implement effective application security. This chapter gave a foundation of methods you can use to protect your programs. The key with most organizations is to limit the number of applications that are used. The fewer applications, the easier they are to secure, and most likely the most productive users will be. We mentioned the whitelisting and blacklisting of applications in this chapter and in chapter 4, and those methods can be very effective. However, there are some applications that users cannot do without. One example is the web browser Edge, Internet Explorer, Firefox, Chrome and Safari are very widely used for mobile devices. Safari, Chrome and the Android browser are common. One general rule for browsers is to watch out for the latest version. You should be on top of security updates for the current version you're using, but always test a new version of a browser very carefully before implementing it. In general, browser security precautions include implementing policies, training your users, using proxy and content filters, and securing against malicious code. Beyond that, different browsers have their own specific methods of security. For instance, each has its own methods for managing cookies, working with trusted sites, using add-ons, turning off ActiveX and JavaScript, and watching for properly encrypted sessions. Use these and other methods mentioned in the chapter to thoroughly secure the browsers on your client computers. Other applications can be secured by implementing user account control UAC, while listing applications through policy, using strong password protection and encrypting data and traffic. As a security administrator, you usually work with applications that already have been developed for you, but sometimes you might dabble in some development yourself. If this is the case, you should adhere to the principles of secure programming discussed in this chapter. The software development lifecycle (SDLC) gives you a methodical process of planning, developing, testing, developing and maintaining your systems and applications while maintaining the confidentiality, preserving the integrity and protecting the availability of your data. Principles should include least privilege, defense in depth, minimizing the attack surface and failing securely. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.